Righto! Right now what we're going to do is do something really exciting called building a VaR example. So right now John C. Hall, his book is known as the Bible for Risk Management. So what we're going to do is actually use a free model that he has online that kind of goes with his book and illustrate how to calculate VaR using VBA, but we're going to use his model as a way to check us. Now I'm going to make a couple of edits, but I'll let you guys know what those edits are and why I'm making each one of those. So I'm going to include this link in the description. What you want to do is download the model building calculations for 3rd edition. This is the one that we'll be working with. So once you can open up this file, cells magically running, enable contents. I know I have to register something. All right. So the very first thing, he has 3 pages here. The first page that he has open on is EWMA. This stands for Exponential Weighted Moving Average, which is a special way how he calculates VaR. We're not going to do this, so go ahead and delete this sheet. Next thing what we're going to do is we have this blank sheet, delete that as well. Now go to the very beginning here, and this is what we're going to be working with. Now, the very first change that I'm going to be making is the way he calculates his returns. He uses a method called simple return. I want to use logarithmic returns. So to do that, just take the ln of this number and divide it by the ln of this number. And throw that all the way down. So you can see that each one of these has the ln represented as so. The next thing that he does is he takes the variance of the population and the covariance of these. This is going to be a pain for you guys, but go here and make these all the sample. So when it says var p, make it .s. Here, where it says var p, make this .s. Alright, where it says covar here, when take this out and make this var.s. Make sure you don't make it 2 different arguments. It only has this one range in here. I made that mistake before. And same thing for this one. var.s. Alright, now for this one, this might be the same thing, I'm not entirely sure, but we want to use covariance.s. Covariance.s and covariance.s. Alright, so just checking that I got my work here done correctly. Oh, missed one. Alright, so now this should flow as normal. Okay, so the first thing that we need to do is build this variance covariance array. Now the way that we want to do this is we're going to build a function for it. So we're going to build 2 functions total. One's going to be the variance covariance var, the other one's going to be a variance covariance array. So open up your VBA and we're going to insert 2 modules. The first module is going to be our var, and that's the one we're going to be working with second. This one here is going to be our variance covariance array function. Alright, so to do this, I'm just going to include real quick the link that you'll need in the comments here, and I'm literally just going to post this in the description. So what I'm going to do first is take a function and we're going to call it variance covariance array, and this is going to have the variable RNG be taken as an argument. Now we're going to need a couple of things for this one. First, what we're going to do is we're going to dim array. This is just a basic array for us. We're going to dim an output array. And this is what our function will take at the very end. We're going to need a couple of index variable, I, j, and k. And finally, we're going to need a return array. And when I said finally, I lied, because we're also going to need worksheet function as an object. And I'm going to need 2 more variables. Alright, so this should be it. Now I purposely just define all these arrays as variance just so they can take many different things. All right, so the first thing that we're going to need to do is we're going to do something called setting the worksheet function, or WF, equal to application.worksheet function. Now what this will do is WF will now act as shorthand for this whole line here. I think it's just an easier way to make the code read. So make the code easier to read. Alright, so now what we're going to do is we're going to first just set our arrays. Our array, we're going to assign it the range so that the values of this range is then put into this array. Now what we need to do is to build our return array using logarithmic method. So to do this, we're going to first size our return array, and to do that we use the redim statement. So we redim our return array, the L bound of our array, comma 1, to the U bound of our array, comma 1 minus 1, and then L bound of our array, comma 1, to the U bound of our array, comma 2. I messed that up. This should be a 2 right here as well, even though it really won't matter. But what I'm doing here is I want to build this right here. This returns this ln, and you can notice that it's 1 minus whatever these are because it needs to have a first element. So we want it to be the same size as the width, which is what the L bound 2 and U bound 2 are for, and we want to do 1 minus the height of this one. So it's L bound 1 to the U bound here minus 1. And now what we're going to do is we're going to just step through this return array. And we're just going to use a for loop with this, and we're going to say return array. Oh, gotta do the J. We need to use a nested for loop. So this syntax here, where you have the L bound and the U bound of the first ones and the L bound and the U bound of the second one, this will step through the entire array total. And now we're going to just say return array I comma j. This is equal to the worksheet function of the ln of our array I plus 1 comma j divided by our array I comma j. Alright, so this here calculates our ln return. This loops through the columns, and this here loops through the rows. So really what we're doing is we're just going like this. This one divided by this one, then we're doing this one divided by this one, this one divided by this one, this one divided by this one, then go down here and say this one divided by this one divided by this one. So now that we have our return array, we are going to now build our output array. So to build our output array, we need to do a couple of things. We need to resize the temp array 2, and the output array. We're going to start with the output array. So the output array, this is going to be 1 to the U bound of the array, comma 2, 1 to the U bound of the array, comma 2. Alright, so this needs to be a square. And it's going to output of the whole function. Now, what I'm doing is I want to build this variance covariance array, and you can see that it's the same as the assets width. So we have 4 here, and then we want like these 4 different assets here to be represented, 4 assets here, 4 assets here. And one other thing I didn't cover before, what we're going to be doing is we're going to be using the covariance. So this one says the variance of the thing here, but the covariance of 2 of the same data sets, so the covariance of this one and this one, so 1 and 1, it's the same thing as the variance, and I'll just prove that to you real quick. Be nice if I didn't make typing errors. So you can see, same exact thing. So in order to do this, we're going to need to size the temp arrays, and we're actually going to be using the worksheet function covariance in here, but we're going to be filling the temp array based upon whatever output array's position says it should be. So this one's a little bit easier. We're just filling in one column of the return array into the temp array, and this will be the L bound of return array comma 1 to the U bound of return array comma 1. And now we're going to take the same exact thing and we're just going to put a 2 here. So those are sized efficiently. Now we're going to loop through the entirety of the output array. So I equals the L bound of output array comma 1 to the U bound output array comma 1 for J equals L bound output array comma 2 to the U bound of output array comma 2, next J, and then next I. Now we have 2 steps here. Step 1 is to fill the temp arrays, and to do that we're going to use another for loop in here, so a loop within a loop within a loop, and we're going to use K for K equals the L bound of return array comma 1 to the U bound of return array comma 1. And we're going to say temp array comma, or temp array K is equal to return array K comma I, and then temp array 2. This is going to be K comma J. So kind of just taking a little breather, what I'm doing here is I'm looping through all the rows in return array, and based upon whether the value for I is here, so it could be 1 through 4, and based upon for the value of J is what it currently is, it could be 1 through 4 as well. It's going to store this in temp array and temp array 2. So effectively what I'm doing is I'm calculating the covariance, or I'm putting the array in and filling it in for each one of these. Now the second step is to store the covariance. Now I'm going to cheat real quick. So output array, it's I comma J, that's the one we definitely want to have. And this is going to be equal to application.worksheet function. Don't write this just yet. Covariance.s and temp array and temp array 2. So I just wrote this application worksheet function here instead of WF like I did up here at the beginning, just so that the covariance would pop up in the box, just to make sure that I'm reading this correctly. Now the very last thing that we need to do is say that our function name, I'm just going to take it from the top, copy this, come to the bottom, and I'm going to assign it the output array, and we're done. So now to check that we actually made this true, select a 4x4 cell, and we're going to use the function variance covariance, and we're going to select our raw data set. Now going back to the top, this here should be the exact same as what's represented here, or I messed up somewhere. So to see if it is, you have to do Control-Shift-Enter so that you can see on the top that this formula is known as array formula, so it has these curly brackets here and here. But I'm going to format this just to see if it's the same. And it should be exactly the same, or I messed up. And very much look like it did work out. Alrighty then. So now that we have this correctly, what we're going to do is now build our VaR function, and we're going to be using this function here in the calculation of it. So our VaR function, what we're going to do is I'm going to call this variance covariance VaR. It's a long title. We're going to have our original range, which we're going to pass just to our variance covariance function that we just built. We need a weights range, and this will be basically how much you have in a certain asset. So if we have like $1,000 in the Dow Jones Industrial Average, it's going to be represented for 1,000 here, and then it's also going to correspond to the columns in range. And then finally we need our confidence level, and this is going to be a double. All right, so a couple of things that we'll need. First thing we'll need is our variance covariance array, which is what we are going to get from our function, but we need somewhere to store it. We need a weights array. We're going to need I as we're going to need it as an iterator, so we're going to make this a long instead. This could probably also work as an integer. And we're going to need this portfolio of variance array, which we're going to be using for matrix multiplication for to calculate, and WF as object again, so that we can do the shorthand, same thing as before. Set WF equal to application.worksheet function. And now what we need to do is we're going to take our var cov array that we have up in our here, and we're going to paste in that function and just pass the range in so that we have our variance covariance array from before. Now what we need to do is we need to size our weights array. So we're going to redim our weights array 1 to the weights range that we have up here that we're getting in our function, and that's going to be the count of it, and it only needs to be one dimension. It actually can only be one dimension. And I also forgot to define one more thing. We're going to define item, and now what we're going to do is for each item in weights, we're going to say the I is equal to I plus 1, and the weights array I is equal to the item.value. Next item. So this is effectively what it's doing. It is filling weights array with the weights in the range. And the reason we need to do this is so that our matrix multiplication is consistent. So if we want to put in weights where, for example, like if we want to put it in like in one row versus just in one column, we can do that still, and it won't mess up our function. So this is just an easy way to control it. Now, what we need to do is after we fill our array, we need to do some matrix multiplication. So here we're going to just take this portfolio variance variable, and we're going to assign it worksheet function.mmult. This stands for using matrix multiplication, and we're going to do the weights array by the variance covariance array. The next thing that we need to do here is reassign it worksheet function.mmult, and this time we're going to be using the portfolio variance in it, this itself and in the arguments, and then we're going to use the transpose of the weights array. Alright, so what this is actually doing is if you go back to Excel, you can see here the portfolio variance. It's calculated here. I'm showing you here on the top in this formula. It's taking the weights array as it's represented here, and it's multiplying it by this, and then it's taking the transpose, which is basically a transpose is you take this and you flip it on its side. So it's multiplying by its transpose to come up with this 8788.23 number. Now let's just test this real quick to make sure it's working. Didn't mean to do that, sorry Excel. So we're going to take our variance covariance, go to our arguments, putting in our alphas, and it's defaulting as a 0.99 confidence value, and portfolio variance 8788.23. So it's the exact same thing as we have down there. Perfect. So the final thing now that we need to do is here, this is our portfolio variance is calculated. Now what we need to do is take this function name, and we're going to be setting it equal to the portfolio variance that we calculated, which now has only one argument in there, and we need to put it to the square root of 0.5 so that it's the standard deviation, and then it's going to be multiplied by the confidence level, which we're going to be using the inverse norm of normal distribution, confidence that we have in here, and this should all capitalize, which it does, and we are done. So just to test this out, you can see here that the 1-day VaR, which is calculated in the final result, is the exact same thing represented here.